Well, we're talking about different kinds of properties of light, and I'm going to do a demo involving one of those properties, which is why the room is dark, so that we can perceive the light a little bit better. In particular, I'm going to talk about flux, which is a fancy term for brightness, and introduce the idea of an inverse square law, which is simply the idea of how the brightness of an object depends on its distance. So what I'm going to do is illustrate that with this light bulb. It's a pretty high wattage bulb, so I'm going to turn it on. It's going to be pretty bright. You can tell that. And I've got a screen behind it, and holding it here, you can see there's a brightness distribution across the screen. In the places that are closest to the light bulb, it has the smallest distance. It looks like the illumination is much more concentrated. Whereas off in the corners of the screen, well, there's still light up here, but it's a lot dimmer, okay? And what I would like you to do is just pay attention to this bright area here as I move the bulb further away or closer. It's a qualitative illustration of the inverse square law for light. When things are closer in, there's a greater concentration of the light coming off from the bulb because it's intercepting so much more. When it's further away, that same amount of light is now spread over a much larger area, okay? And so in a small area, it's got a smaller share of all the light that's coming out in this direction. Here, each bit has a bigger share. When it's further away, it's a smaller share. So brightness depends on proximity. That's the concept of the inverse square law, and it's the idea lying behind the sense of flux, which we use interchangeably with the term brightness.